Electronics 01, 1st of July 2020. Ohm's Law. Sorry about the buzz in the audio, but I've got the aircon on. It's too hot. Right, hi everyone. Electronics 01. Now, normally they'd start off with electrons, atoms and things like that. Well, I'm not going to go there. I'm going to start off with Ohm's law. The first thing is, do you know what a volt is? Can you explain a volt? Hopefully by the end of this you'll know exactly what a volt is, you'll know what an amp is, and you'll know what resistance is, and you'll be able to explain to anybody exactly what they are. V equals volts equals the charge, the unit of volts stored in a charge. Volts will always be accompanied by current, but volts and current are two separate entities. I equals amps equals current, the unit of amps stored in a charge of volts and current. R equals ohms equals resistance. The ohm unit of resistance between positive and negatively charged volts and current. Volts and current discharge via high or low resistance. Now you know the difference between volts, amps and resistance, and you can explain what each one is. Now we'll press on to Ohm's law and the first triangle. And here we have the Ohm's law, first triangle. Volts, amps, ohms. So volts equals I times R. I equals V divided by R. And R equals V divided by I. So V divided by I equals R. V divided by R equals I. And I times R equals the voltage. Now down below, this is how you will normally see them. V equals I times R. Sometimes you won't see that asterisk there, or star. That's on the number 8 key on a computer keyboard. And most mathematicians, when they're writing out Ohm's law stuff, do not put a roadmap sign there. And people like me forget, oh, you got a times I by R. Because I'm self-taught. Never taught this in school. And so that's what I use to remind me it's the times. Can't put a cross because that would be an X. And an X we will need an X to say what is something. Now I equals V divided by R, and R equals V divided by I. That's how you will see them written from now on. Yes, I did say I'm self-taught right up until the age about 22, and I decided I'm out of work, I can't get a job. They all say you need qualifications to do that, you need qualifications to do this, even just to be a household electrician you needed qualifications. So I said, right, what's the government doing at the time? And they suggested that down at the unemployment exchange, go back to college. I can go back to college full time. And I said, are you sure? What do I exist on? They said, oh, you still get your dole money. So with that, my second chance at education wasn't going to be let slip by. So I went to college. When I got there, I had an interview, and the teacher, well, they're not teachers, they're lecturers. That's what they're called, is lecturers, because they lecture. They don't teach, they lecture. There's a total difference between a teacher and a lecturer. A lecturer will try to inspire you to go away and do your own research. So don't get confused between a teacher and a lecturer. Okay? And I've met some lecturers in my time that couldn't teach their way out of a paper bag. And I've met some lecturers that are fantastic teachers and won't give up on you and help you very greatly. Anyway, digressed. So off I went to college for the next 3 years because unemployment was diabolical. And because I was at college, I didn't get pestered by the dull people. I didn't even have to sign on, if I remember correctly. It's so long ago. Anyway, eventually, 3 years later, before I could get into college, that's what I forgot, before I could get into college, they wanted to give me a test. And they said, what's your English like? And I said, absolutely diabolical. I can read perfectly, but I can't spell because I'm dyslexic. Ah, right. He said, do you know what a circuit diagram is? I said, yeah. He said, so he pulled out a circuit diagram of a television, all black and white TV. And he said, can you point me to the rectifier? I said, right, yeah. Well, I can't point you to the rectifier, but I can point you to that diode, and all diodes are rectifiers, whether they are full wave rectifiers or a half wave rectifier. They're all rectifiers. And with that, a big smile came across his face, and he said, yeah, you're in. You can join. You've explained exactly what I wanted you to explain, and you pointed out on a circuit diagram a diode. He said, just for keeping it going, what's that? And he pointed to that. I said, well, that's a 100 microfarad capacitor. And he said, okay, what's that? And I said, that's a 10k resistor, you know. He said, yeah, well and truly, no problem, you can join the second year. I didn't have to do the first year. It was a 5-year course that I'd started. So I joined the second year because he knew that I knew exactly what I was talking about by looking at a circuit diagram. Anyway, 3 years later, and cramming in the chance to do a computer course as well at the same time as I was at college, I'd done a computer course and I'd done the electronics course, and at the end of it I had City and Guilds to now prove I'm a fully qualified TV engineer, fully qualified audio engineer, fully qualified video engineer, fully qualified communications engineer. I also passed and done my amateur radio license while I was at it, and I got a first, or the highest possible mark you could ever get in the computing course that they'd done, and hence that was done on an old Sharp's Z80, and part of the course was you had to build a computer, and I built two actually. I built one with a 6502 processor, and I built one with a Z80 processor. Very rudimentary, but they upped and worked. And as I say, I got the highest possible marks you could ever get in the computer course. So I walked out of college with letters after the name of IEEE, and went on. That's how it went on. Now I'm retired and I just play. So I'm going to pass on the knowledge that I learned and things to you. Hope you like this course. Now we do some practical, some actual sums. We're using the Ohm's law triangle. So let's say we've got 240 volts. I'm going to make this bigger first. We want it bold. Let's say we've got 240 volts divided by 13 amps. Right, 240 volts divided by 13 amps. Now then, equals R. But we don't know what R is. So how do we find out? We just do the actual sums. Pull that down to there. Let's go and do the sums. Right, so 240 divided by 13 equals 240 divided by 13 equals 18.461. So 18.461, and that's ohms. Oh, what's that? The OHM'S. That's ohms. Now, what we're going to do is prove the other two figures with this, what we've got. So what can we do? We can go 240 divided by I'm going to cheat, copy, I can get the mouse to move, paste. Right, 18.461 equals, so volts divided by resistance will equal amps. Equals, let's do the sum. 240 divided by 18.461 equals 13.000. 13.123. So 13 amp equals 13 AMP. So we've proved with the other two figures that 13 is correct. Now let's prove the mains voltage, the 240 volts. So how do we do that? We go I, which is 13, times, I'm going to use the asterisk mark as times. Most mathematicians won't use this, they won't put anything there. Well, I'm self-taught and I always forget that it's a times. So if you put the times in there, you can't use a cross, because a cross will mean an unexplained value. We don't know the value. I'll show you what I mean when I write this sum out. So 13 times the ohms, which is print B should still be there, yeah. Space there. Equals volts. Equals 239.993. So 39.993, and we can round that up to 240 because we've got all nines. So there you go. So we've proved every action of that. We've proved the ohms, which we didn't know because we only had volts and amps. So R at the time up here was X equals R, because X, we didn't know what the value of X was, and X equals R. So there you go, we proved that the, I'm trying to get that to the top, we've proved that the X equals R, we've proved that that was the ohmage, we've proved that that divided by that equals the amps, 13 amps, and we've proved that the 13 times 18.64 resistance, the ohms, equals volts, equals 239.993, and when you round that up because of all the nines we can call it 240. So we've proved beyond doubt with maths that that works. I will just put this, try and get this all on screen. No, that's as good as it's going to go. So we've proved beyond a doubt that that actually works. So there's the first triangle. Right, if you want any more information about volts, amps and resistance, I've left all the links down below the video in the description, and all the links are there for you to go away and do some of your own research to see how old the volt is. When was it first invented? Who invented it? Same for the watt. Who invented the watt? Who invented the amp? Where do they come from? See what your research gives you. I've left you 3 links down below to do it. If you like this one, drop me a tip and I'll continue with the next one, the next lesson in electronics 01. Well, the next one will be electronics 02. Thanks to all my followers and my patrons and everything like that. And if you want to send me something to review, strip, tear down, whatever, the address all in the description. Or if you can't find it, go on Facebook. You'll find me on Facebook, john.lovatt.524. If you're not a Facebook member, you can go on my YouTube channel, which is uksuperrascal, all one word, and in my about section is my address and all my information. You can get in touch, or if you want to send me an email, that's howtofree@yahoo.co.uk. And yeah, spare me a couple of housey B for coffee, as they say. I don't drink coffee. Tea, cup of tea. Cup of tea and a bun. There you go. Right. So there, you can got my details on how to contact me. Now, 35 seconds of voice over text for YouTube ads. Almost got 200 library.tv followers now. Thanks for watching. Now click the YouTube subscribe and bell icons. Thank you for watching. The end.